In today's session at Medical Sciences Made Easy by Naphtali Muhumuza, we want to discuss on hematological indices calculation, or what we call red cell indices. In the previous video, we have looked at how we can interpret using both hematological indices, and we gave the formula. And in this session, I want to show you how we can calculate them, so that you can always double check your automatic analyzer. And we always remind you to subscribe if you haven't subscribed. Share your comments and like the video. The importance of liking the video is that we can always be energized to make more and more. It tells us that you are learning a lot from us. So we are having a question here which we want to try. We want to see how can we calculate these indices. When we are provided with total red cell count with the PCV, but on the automated analyzer we call it hematocrit. Is always in a percentage, and when we have also HB as 8. So when we are given total count as 4.5, in the previous video we saw that the RBC count should be in 10 power 12 cells per liter, the PCV should be in a percentage, and HB should be in grams per liter. So whenever we are given in grams per deciliter, we can always convert. And we saw also how we are going to be converting, and we are going to begin by answering this question, where we are going to begin with the part A, where they require us to calculate MCV, MCH, and MCHC. So we want to begin with calculation of MCV, and MCV we saw under the formula is equal to PCV divided by total red blood cell count, and this red blood cell count should be in 10 power 12 cells per liter. And we saw it is measured in femtoliters, so we shall convert at the long run. So this PCV should be in decimals or liter per liter, what we can call decimals. And we already have our PCV at 30%, so we know that PCV is equal to 30%, which is the same as 30 divided by 100, and you get 0.3. That is the PCV. Then the total cell count is already given here, so we are going to substitute, whereby our MCV is going to be equal to 0.3, which is the PCV in decimals. Then we divide by the total count, which is the 4.5 times 10 to power 12 per liter. And this is equivalent to 0.3. You divide by 4.5 times 10 to power 12, then you divide by 1 liter, because this is per liter. Per means division side. And we can always work on this by saying 0.3. Then you divide this one. I'm removing this and I'm putting a division side, divided by 4.5 times 10 to power 12 over 1 liter. And this is always over 1. Then I can call it over 1, or I can say this is 3 over 10. And this one I will be able to get 0.3 over 1. Then when I remove a division side, I take the reciprocal of this fraction, whereby when the liter which is down goes up and this one goes down. So when I remove the division side, I take the reciprocal of this fraction, which becomes 1 liter over 4.5 times 10 to power 12. So after getting this, the final will be 0.3 liters divided by 4.5 times 10 to power 12. But remember, MCV should be in femtoliters. So after getting this, we have to convert these liters into femtoliters. So the next step we shall be required is to a liter to femtoliters. And we know that 1 liter is equivalent to 10 power 15 femtoliter. So where there is a liter here, we are going to substitute it with 10 power 15 because we are converting the liter into femtoliters, because the results of MCV should be expressed in femtoliters. So we are going to see if we come and substitute where there is liter with 10 power 15, we are going to get our MCV equaling to 0.3 then times 10 to power 15 femtoliters. Then we divide by 4.5 times 10 to power 12 cells. So at the end, at the long run, since these ones are the same, and according to rules of indices, whenever you are dividing and the bases are the same, you subtract the powers. So we are going to get 0.3 divided by 4.5, then times 10, and since they are of the same powers, we shall subtract the powers, we get 15 minus 12. And at the long run, we shall remain with 0.3 times 10. And when you get 15 minus 12, that one is power, we'll get 3 femtoliters divided by 4.5. And the final answer of this, we shall get 65 femtoliters. Therefore, the MCV of our patient is equal to 65 femtoliters. And the reference range of MCV is always 80 to 100 femtoliters, meaning our patient has low MCV. So this is how we can calculate it, even without a calculator. You can always use rules of indices to come up with. So what we have done here is to know that it is in liters, but the answer we want it in femtoliters. But we know that a 1 liter is the same as 10 power 15 femtoliters. So where we have a liter here, we substitute it with 10 power 15. And then we use rules of indices that whenever you are dividing and the bases are the same, you subtract the powers. That's why we have got 15 minus 12. And we got 10 power 3, which is 1,000. And when we get this one times 1,000, that is 300 divided by 4.5. And the 300 divided by 4.5, you get 65 femtoliters. That is part 1. Then another one, they also require us to calculate MCH, which we need to know. And we know that MCH is equal to MCH, which is mean cell volume, is the same as hemoglobin in grams per liter. You divide by the total RBC count in 10 power 12 per liter. And when we have this, we already have our HB, which is, we are given HB as 8.0 grams per deciliter, but remember we need it in grams per liter. So to convert grams per deciliter to grams per liter, we multiply by, we are going to get 8, so we get 8.0 times 10, and we get 80 grams per liter. Because we know 1 liter is the same as 10 deciliters. So if you know that 1 liter is the same as 10 deciliters, then when we are converting it to grams per liter, it becomes 8. So after doing that, we come and substitute. Already we have our total count. So we shall find MCH equaling to 80 grams per liter. 80 grams per liter means divided by a liter. Then I put a division sign. Before this, I can first put all of them, grams per liter. Then we are dividing by total count, which is 4.5 times 10 to power 12 per liter. And this one is the same as 80 80 grams divided by liter. Then instead of putting this, I'm going to put a division sign, which is 4.5 times 10 to power 12 divided by 1 liter. That is what we are doing. And whenever we have this, we can remove this division sign by taking the reciprocal. Whereby 80 grams divided by 1 liter times this one which is down goes up, this one goes down. That is the reciprocal times 1 liter divided by 4.5 times 10 to power 12. And this liter is going to go with this liter. We shall remain with 80 grams, then divided by 4.5 times 10 to power 12. But remember, MCH is measured in picograms, so we have to convert gram. The next step is to convert, we are required to convert grams to picograms. And we know that 1 gram is equivalent to 10 power 12 picograms. And after knowing that one, so where there is a gram, I'm going to replace it with 10 power 12 picograms. So we're going to get our MCH equaling to 80. We are substituting here where there is a gram. We are putting 10 power 12 times 10 power 12 picograms, because we have known 1 gram is the same as 10 power 12 picograms. Then we divide by 4.5 times 10 power 12. Then from this step, that's when we shall apply rules of indices, that whenever you have the bases and they are the same and you're dividing, you subtract the powers. So we shall get 80 times 10, then this is 12. So this one, because they are the same, we are going to subtract the powers. You subtract by 12 over 4.5. And when you get 12 minus 12, you shall remain with 80 times 10 power 0 over 4.5. And any number which is powered by 0, it is 1. So we are going to get 80, 10 power 0 is 1. You divide by 4.5. And the final answer of MCH will be 17. If you can put it on your calculator, 80 divided by 4.5, you get 17.8. But remember, it is picograms. This is picograms. It is in picograms, and its reference range is always between 27 to 32 picograms. So meaning still this patient of ours has low MCH. So this is the MCH. After getting MCH, now we can calculate MCHC. Because another question they want us is to calculate MCHC, which is mean cell hemoglobin concentration. The amount of the concentration of hemoglobin in a single red cell. That is mean cell hemoglobin concentration. So after knowing this, we have to also calculate the MCHC. And for MCHC, mean cell hemoglobin concentration, which is the concentration of hemoglobin in a single red cell, it is equal to, you get PCV, mean cell hemoglobin concentration. It is determined by getting HB, that is hemoglobin, in grams per liter. You divide by hematocrit, what we can call PCV when it got manually. You can calculate it by that. And remember, we are given hemoglobin, and this hemoglobin it is in grams per deciliter, so we convert it the way we converted it here. So our HB is now going to be 80 grams per liter, and our PCV is equal to 30%. That is divided by 100, which is 0.3. So now our MCHC will become 80 grams per liter. You divide by 0.3. And when you do this, when you divide this by 0.3, it is the same as 80 grams per liter. You divide by 0.3 is the same as 3 out of 10, which you get 80 grams per liter times the reciprocal, which is 10, divided by 3. You get 800 grams per liter, you divide by 3, and you are able to come up with the final answer of 266.7 grams per liter. So this is the final answer of MCHC, what we call mean serum hemoglobin concentration. So after we have got both MCV, which is low, we are seeing MCV is low. According to reference ranges, we are seeing MCH, that is mean serum hemoglobin, which is the amount of HB in a single red cell, is also low according to the reference ranges. And we are also saying MCHC, its reference range is between 315 to 360 grams per liter, or you can say 31.5 to 36.0 grams per deciliter. So this one is also low. And after seeing it is low, before we comment also part B, they want us to calculate Mentiza index. And in the previous video I told you Mentiza index is the one that we can use whenever we have a microcytic hypochromic type of anemia to confirm if someone has either iron deficiency anemia or thalassemias. So we are going to calculate the Mentiza index, and this Mentiza index, which is part B, the Mentiza index, which is the ratio, is got by, you get MCV, and you divide it by total RBC count. And our MCV is 65, and 65, you can put it on the calculator. Please, you can put it on the calculator. 65 divided by total red cell count, which is 4.5. So you get 65 divided by 4.5. That will be the Mentiza index. So after getting, you guys hope you are calculating. It is, we are getting 14.4. 14.4 is our Mentiza index. And whenever this Mentiza index, in the previous video we saw, if it is greater than 13, it confirms iron deficiency anemia. And if it is less than 13, it confirms thalassemias, which is a type of microcytic hypochromic type of anemia. So because we are seeing our Mentiza index is above 13, this one gives assurance that this patient of ours might be suffering from iron deficiency anemia. And still this one is being backed up by the red cell distribution width, which is also high, 16.5%, which is still high. So whenever we told you that iron deficiency is confirmed, especially in children whereby Mentiza index is above 13 and RDW is high, you can confirm, you can distinguish between iron deficiency anemia from thalassemias. So on the comment, we're going to say this patient has a microcytic hypochromic type of anemia. And according to our Mentiza index and red cell distribution width, this one is more of suggestive of iron deficiency anemia. So if we want to confirm, we can also recommend for other tests, which is serum ferritin and serum transferrin plus total iron binding capacity, to confirm if really this person is having iron, because these ones do not confirm very well. They are not a confirmatory. They suggest, they are a differential. Here we are just distinguishing between thalassemia and iron deficiency. But if we want to confirm iron deficiency, we do serum iron profile, which is the ferritin, transferrin, and total iron binding capacity. So this is how we can always calculate these hematological indices. And I want to end by giving you an exercise which you'll be able to, under the comment section, you'll be able to put your answers and we shall be able to interact together. And the question is that when you are given, if you are given that this is the exercise, given that the total RBC count of the patient X is 2.39, and the hemoglobin concentration is 7.3 grams per deciliter, and the hematocrit, or what we call PCV, is equal to 20.6%. I want you to calculate MCV, MCH, and MCHC. Then you comment on the results. So this is the exercise I'm giving you, and make sure after you have calculated, you share your answers under the comment section so that we can learn more together on our channel. Thank you so much for listening. Remember to subscribe. Remember to share your comments, especially this exercise, and share to others. Thank you so much.